We're at the top of the Chehalis world. We're in the high alpine on a small bedrock outcrop, kind of peeking above some glaciers that have been here for thousands and thousands of years. And knowing that the Chehalis people have used all different areas of the landscape, they used the very peaks to be able to show that people went up to the top of the mountain, collected the quartz crystals, and actually left some things behind. It got us thinking the significance of the alpine areas, the significance of all waterways and corridors and transportation routes that would get people up here. And also pondering why it is that people would come to some of the most isolated, exposed and vulnerable places. And there's no simple explanation for that, but we're going to try to figure some of that out through coordinated efforts of a number of expeditions where we've identified the entire extent of the archaeological materials now. And now we know, whereas before we had 2 artifacts, now we've got dozens that all paint a really compelling picture of this being an important nexus. So we have a number of really important research questions that are going to help us understand how the ancestors of the Chehalis people use this area. And we've been looking at that with students that Adam Palmer has brought up, so on 2 different expeditions now. We also have a geochemist who's able to look at the bedrock and help us understand not only more about how the quartz crystals arrived here in the first place, but also about where some of the other materials are being brought in from. And that will give us clues to where the people are from that were visiting these places, or where they were able to trade in artifacts from. Now, some of the tools that we found up here are extremely ancient technologies. Microblades, for instance, have been around on the northwest coast for 10,000 years. So people have likely been using this spot for many, many, many thousands of years, likely always dependent on these cycles of glaciation. We know over the last 10,000 years there would have been times when this entire bedrock outcrop would have been covered in snow 12 months of the year. And yet in spite of this, people have been able to come back here over and over again. So with all of the significance of this landscape and all of the millennia of years that people have come up here and gathered the crystals at this sacred place and left materials behind in some sort of exchange. One of the things about us being able to demonstrate that this is an archaeological site through the material remains of the artifacts is that we can get protection for it through the Heritage Conservation Act. We know that Chehalis people were up here at the one village on the main beach, right around where the large dock is. We found thousands of these, and many of them end up being worked into quartz microblades and small cutting tools. Some are even projectile points, and a lot of them are pendants. They had any number of uses. Having all of these quartz crystals up here and then down at the ancestral villages really does help us to draw a very direct line. So for all of these reasons, it's incredibly important for us to try to extend some protection to this vulnerable and significant place.
As a geochemist and archaeologist, one of my main goals is trying to connect people to the landscape by looking at the tools that they used, the materials that they're made from, and where they might have collected those materials. And the material that we're particularly interested in up here is quartz crystal, which is exceptionally rare in such beautiful form in the geologic record. The materials we're working on down in the lake area are volcanic ashes and things like that seem to be toolstone grade. So things that were spat out of a volcano perhaps millions of years ago that have been transformed into these amazing toolstones that we might actually be even seeing brought up to this 7,200 foot elevation where we're finding quartz crystals floating around on the surface, as I can grab just here. And by looking at the chemistry of these materials, we can start getting an idea of where they originated and why they might have been chosen. For example, do they have high quartz contents? Do they have particular characteristics that might have been useful for making specific things? Do they have cleavages that might make nice slaty knives? Do they have conchoidal fractures or shell-shaped fractures that might make really good bifaces like we see near the community? And start working through all of that in this exceptionally complex geologic puzzle where we can start getting important archaeological details recorded not just in finding the artifacts, but actually in what they're made of and where perhaps those materials came from. Quartz is actually one of the most common minerals on the Earth's surface. And usually when we find quartz, it's in the form of rocks like this, or rocks where you can't actually see the individual crystals. And it's not really something that we can isolate and use as like a tool stone itself. But what's exceptionally unique about this place is how it formed. And it formed in such a way that it cooled from a magma, a liquid rock, so slowly that the quartz doesn't just show up as little grains in a rock. It actually shows up as full-on quartz crystals. Now these are pure silica practically, so they're exceptionally sharp when fractured and they make beautiful stone tools. But up here is one of the few spots that you can find such crystals in a high abundance enough that it would be worthwhile making the trek up here. And that's purely based on the geology of this particular rock unit, which is called a pegmatite. And that means that it cooled at a very low temperature and very, very, very slowly, enough so that we could produce massive amounts of these crystals, which go from small ones like I've got in my hand here all the way up to the size of your forearm, which are exceptionally beautiful. So it's a rare spot for not only the fact that there are beautiful rocks here and very useful rocks here, but we've also found on top of that, in the sediments deposited on this outcrop, we found archaeological materials, artifacts that are composed of rocks that you can't find here. So by seeing that and by acknowledging that these are artifacts, these are composed of materials that do not come from this rock unit, and this rock unit is full of exciting materials itself, it shows already that there is an exchange or a use of this landscape where there would be people bringing materials here and taking materials away from here.
One of my objectives in coming up here now with students is to help protect the site and keep the knowledge and the history preserved through education, by bringing up students, by bringing up the right people, the archaeologists, the geologists, and for this site to be recorded and to be preserved in history. As an outdoor education teacher, I think it's important for the Chehalis students to come back up to these sites, to come to these traditional sites where their ancestors were hunting, were using and gathering tools, and to live and be in those spots. Landscape is everything in history. History and the landscape is all tied together, and this is, we're essentially in history being up here. Wherever you look in the world in ancient history, crystals had a significant part in legend and lore and storytelling and teachings. And now we're here, right above Harrison Lake, in an island of crystals. So this could be an area that was used as an important trade route, gathering site, but geologically it's fascinating. And for that reason, it makes it a rare site for the people that lived here back then and also now. It needs to be protected, it needs to be documented, and it needs to stay in the history. And teaching outdoor education and mountaineering and wilderness skills, my mountain skills program at Chehalis, one of the objectives of that course is to actually use tie the landscape into our skills. So we aren't just going on mountaineering trips and climbing mountains, but we're actually going to areas where their ancestors would have been climbing, where their ancestors would have been goat hunting, tying in those skills into the land. Landscape is everything. I mean, if you are mountaineering, what's your objective? Why are you there? And one of the objectives of my course is to go to these areas that had significant historical use. So it's kind of a history lesson and a wilderness skills lesson all in one. So it gives us a reason to go to these places, but also to connect them better to the landscape. It's all about connection. If we're not connected to the land, we have a harder time to protect it. But if we can get our students connected to the land, to show them the historical importance and also just the fascinating science behind the land, the geological importance, the historical importance, when they're climbing that mountain, they're going to be more prone to protect it in the future. And that's what we need to do with our students, is we need to not only just teach them the skills to climb the mountains, but actually connect them to the mountains. If they're connected to the mountains, if they have the skills to climb those mountains, we will protect them and we'll have them in the future. So we're up here with Justin, Hayden, Jared, and Steve, part of the Mountain Skills Wilderness class. And one of our objectives of this trip is to document, survey, and further explore Crystal Island. We're here with Morgan, the archaeologist from Chehalis, and Rai, geoscientist from UBC. And together as a team, we are basically helping to document and survey this site for protection in the future.
Another flake. And this one here is a microblade.
That's awesome.
Really thin, sharp blade that could be used for cutting. So guys, I just wanted to show you a small cross section of some of the artifacts that we picked up. Basically, when you look at the ground here, what do you see? It's quartz crystal. It's a lot of these granitic rocks. It's brown sediment. And then you see how different these rocks in my hand are. Can you see that it's very different than the other rocks on the surface? They probably would have been brought in as little cobbles, and then they would have been flaked. And we found those ones just over there. There's a whole series of these kind of inset into a piece of antler. So you would have to kind of carve a thin little line, like a groove in the antler, and then you would place these side by side. And so it's very possible that whoever was there was actually produced enough of these, and maybe they even had some bone or some wood that they could have, put it into using some sort of pitch to it kind of adhered a little bit. The other neat thing about this is, Rai can take these materials, and by doing some geochemistry, he can actually, figure out where some of these materials might have come from. So some of these could be coming from all the way, as far as Garibaldi or somewhere in the interior. Other ones like this maybe came from places like Echo Island or Morris Creek. And so what each one of these does is it kind of tells a different story about people being on this landform. That's a bit of a cross section of what we're finding here.
So if we look at these rocks here, all those little spots you see, so all the little tiny different colors, the blacks, the whites, the grays, those are all different minerals. And minerals out of a magma, a liquid rock, they crystallize and form themselves out of the liquid. And if that happens really quick, the crystals they form are super tiny. That's what you're seeing there. So from a lava, something on the surface, it cools really quick because it's in contact with the atmosphere or in contact with water. So it's going to basically quench it and make all of the crystals so small they all form at the same time, and they can't grow to be big individual crystals like in these granodiorites. But these ones and all of this stuff around here cooled underground still. So it wasn't in contact with the atmosphere, it wasn't in contact with the ocean, and that made it cool a lot slower. So some minerals crystallized first, and they could form nice big ones, and other minerals might crystallize next, and they could form nice big ones, and you end up with this interlocking mash of crystals on a bigger scale that if you were to break them, you wouldn't be able to control how you fractured it, right? So this stuff is also going to be way harder to break because the crystals all lock.
Yeah.
In these ones, you're breaking the individual crystals apart. That's what's creating the sharp edge, right? It's actually the quartz fracturing in the same way that the crystals do on a microscopic scale in these, and along with other minerals, that's making that really sharp bit that's used for cutting. So if those are big fat minerals, they're not going to work so well. So things that this might be good for is bashing rocks to make your stone tools, right? Using these hard granitic rocks as a hammerstone to break the fine-grained rocks makes them a useful stone tool in another capacity. So I'll get you guys all bags, and I'll put your names on them, or you can put your names on them. And then I would suggest that anything you find that's suspicious, chuck in the bag, and we'll take a look at it later. Does that sound good?
Yeah.
So I'll go grab four nice little sample bags for you.
Let's walk up here to where it is that we
I'll get you over there.
Why don't you wear your boots?
Where did you find it? So it's just sitting right here, just kind of on the edge. And you can see the nice spine down the back on the dorsal side. Let's move on the ventral side.
So you guys see
You
they're
found
just
that?
kind of
Yeah.
popping up
Really?
all over the surface. So
That's sweet.
You just found one
You just found that?
And it makes the other minerals like really crumbly. So that's kind of what's happening there.
Do a cross section of that ice in there. Because we don't need all of this.
Really helped them in the outdoor.
All right. Always have safety on.